We are back with lesson 12.2 for intermediate algebra. This is adding and subtracting functions. So our problems are going to look, instead of just like f of x equals a number or f of 5 equals something, we're going to have things like f plus g of x or f minus g or g minus f of x, things like that. Okay, so function notation, that reminder, f of x, g of x, and h of x, just say which function we're talking about. So it directs your eye to the correct function. Okay. When there is a plus inside your problem, like this f plus g of x, what that means is that you are adding. And when you add, you combine like terms. Okay. So the notation may look a little bit weird. It will say something like f plus g of x. So f plus g will be in parentheses, and then there will be an x, or a number perhaps. What that means is that you have your first function, which is f, and then whatever number or letter that is, f of x in this case, and then your symbol, which is a plus. Okay, now your next function is a g, and then you use parentheses for whatever number or letter that is again. Okay, so that x gets used for the f and for the g, and then in between those two functions you put whatever that symbol is for the operation. Okay, so we are going to be adding together our functions f of x and g of x. That's all that means. For subtracting, you're going to have to do a little bit more. So the first thing after rewriting is you're going to distribute your negative sign. So we've done this before. We've done like all of this stuff before. It just looks a little bit different. So we're going to distribute the negative sign to the whole second parentheses, and then we will combine like terms. Okay, just like in the previous problem, f minus g of x means you're going to have f of x. You're going to have g of x. And then you have a subtraction sign in between, so minus. Okay. Once you get this idea set up in your mind, you're going to have one set of parentheses for your f of x function, whatever that polynomial is, one set of parentheses for your g of x function, and then that minus in between them. So let's see how that plays out. So let's try one of each operation with the following functions. So f of x, let's use green for that, and we'll use blue for g of x. Okay, so this f plus g of x is the same thing as f of x, which is this guy, plus from this guy, and then g of x is going to be our second set of parentheses. So that's how you break it up. And we're still using the letter x, okay, not plugging in a number for that. All right, up above it says g of x is 5x minus 3, and f of x is 6x minus 1. All right, since this is adding, we are just combining like terms, like way back in chapter 7. Okay, 6x plus 5x is 11x. And negative 1 plus negative 3 is negative 4. Okay, so f plus g of x is 11x minus 4. Okay, notice that when we are doing these functions, some of them are ending up with x in our answer instead of just like a solid number as the answer, and that all depends on whatever is in the set of parentheses there. Since this has an x, that means our answer is going to be a function, not a number. So answer has x in it, if this is still an x. Compared to on example number 4, where we have a number inside instead of an x, we're going to get a number as our answer. All right, let's take a look at example 2, f minus g of x. So we're going to have f of x, and then a minus, and then g of x. Okay, g of x is 5x minus 3. And f of x is 6x minus 1. Okay, in our instructions up above on the subtracting problems, the first thing we want to do after the setup is distribute the negative. So this negative that's right here, treat it like a -1 multiplied times that second set of parentheses. So -1 times 5x and -1 times -3. And when we do that, the in-between number, or in-between symbol, changes to a plus. So it uses up that minus that is in between. Okay, so our second set of parentheses now becomes, let's see, -1 times 5x is -5x, and -1 times -3 is +3. So all that's really changing is every single sign in that second parentheses has changed. Okay, our first set of parentheses, that f of x function, did not change because there was no number multiplied on the outside over here. There was no negative. So it just stays the same. All right, once you have distributed that negative, you're just combining like terms. So let's do that. 6x plus a -5x, or 6x minus 5x is just 1x, x. Then -1 plus 3 is 2. Okay, so f minus g of x, which I'm getting from the original problem up there, equals x plus 2. Okay, example 3. This is backwards from the problem that we just did. We are subtracting still, but we have g first and f second. Okay, so our g of x function is 5x minus 3. F of x function was 6x minus 1. Okay, since it's subtracting, treat it like a -1 multiplied times the second parentheses. So -1 times 6x is -6x. -1 times -1 is +1. And that first function you just bring straight down. Okay, now let's combine like terms. Okay, 5x plus -6x, or 5x minus 6x, is -x, or -1x. -3 plus 1 is -2. So that's our function, and we write on the left g minus f of x equals. Okay, now hopefully we notice that examples 2 and 3 are very, very similar, but they're opposites. Okay, notice the x and the 2 are both positive up here, and the x and the 2 are both negative down here. So if you switch your f and your g functions to g minus f, then you end up with literally just the opposite of what you had before. Okay. Example 4, g plus f of -4. So let's first find g plus f of x, figure out what that function is, and then we'll plug in the -4. Okay, so g is 5x minus 3. We are adding, so I'll put a plus. And then f is 6x minus 1. So we're first finding g plus f of x. Combine those together. So g plus f of x equals 5x plus 6x is 11x. -3 plus -1 is -4. Hey, look at that. We've seen that before. So it looks like g plus f of x is the same thing as f plus g of x. Same exact thing. Now, remember that if you add two numbers together or you switch their order, you get the same thing. Like 2 plus 3 is the same thing as 3 plus 2. That's the commutative property. So you are allowed to switch when you are adding, just switch the direction, and you get the exact same thing. All right, from here, let's plug in our number, which is -4. So this is going to be g plus f of -4. I'm going to put parentheses for all the x's like I did in the last section. Okay, so for negative 4, I'm plugging that everywhere we had an x, and then we work it out. Okay, 11 times negative 4 is negative 44. Bring down the negative 4. Negative 44 minus 4 is negative 48. All right. In the next set of problems, I went ahead and typed f of x, g of x, and h of x into my calculator, into the y equals. So you might want to pause the video for a second, go into your calculator, and type those three functions in. So you're ready when we get to the problems where we use the calculator. Right. Example 5 says find h plus g of negative 5. Well, that's the same thing as h of negative 5 plus g of negative 5. Okay, so it looks like we could find h of negative 5 using the calculator, using that table. We could find g of negative 5 in the calculator using the table, and then we could just add those two answers together. Okay, so this is the exact same type of problem as example 4, but we're going to use the calculator instead of working it out by hand. Now, it really doesn't matter which way you do it, so I'm going to use the calculator. Okay, h of x was my third function that I plugged in, and g of x was the second function that I plugged in. So I'm going to hit second graph to get to the table. The number we're plugging in is negative 5, and it looks like I am not quite up to negative 5 on my x's, so I'll hit up a couple of times. Okay, so if x is negative 5, f of x, or f of negative 5, is negative 8. G of negative 5 is 18. Ooh, we need that one. G of negative 5 is 18. And then that third column, y3, h of negative 5 is 93. So all we have to do is now add together 93 plus 18, and we get 111. So the calculator saved us a whole bunch of work. Taking a look at example 6, though, the calculator is not going to be much help, and that's because we are not plugging in a number. We're plugging in an x. So we know that our answer is supposed to still have x's in it. Okay, fine. What we're going to do instead is take negative 2 times that f of x function, so we'll end up distributing, plus 3 times the h of x function. Okay. So we have negative 2 times f of x plus 3 times h of x. So see how that structure stays the same. F of x gets replaced with x minus 3. H of x gets replaced with 4x squared minus 7. But the negative 2 times the f is still there, and the 3 times the h is still there. And from here, this becomes just a simplifying problem. Let's do it. Let's distribute and then combine like terms. So negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. 3 times 4x squared is plus 12x squared. Don't forget that plus sign. And 3 times negative 7 is negative 21. Let's combine like terms. We want to put this in standard form, so we scan and find the biggest exponent, which is a 2. So 12x squared is going to go first. Okay, so that was this guy. Negative 2x is going to go second because it had the next biggest exponent, which is an invisible 1. And then our last two terms are like terms. Positive 6 minus 21 is negative 15. Okay, so our original problem equals 12x squared minus 2x minus 15. We are not plugging a number in because it still had x's inside those parentheses. Okay, number 7, however, we are plugging in a number. So what this says is h of negative 2 minus f of negative 2. Let's get that separated out so we can see it. H of negative 2 minus f of negative 2. This negative 2 does not mean multiplied times these guys. It does not mean h times negative 2 and f times negative 2. It means we are plugging negative 2 into those two functions. All right. So since we're plugging in a number, we can totally use the calculator on this. Okay, h was y3 and f was y1. Okay, we are plugging in negative 2. Okay, so h of negative 2 is 9. Right, here's the negative 2 for x, and our third column, y3, was h, so this is a 9. And then f of negative 2. F was our first function we plugged in, so if x is negative 2, f of negative 2 is negative 5. I'm going to use parentheses around that negative 5 just because it's the second thing that we are writing down, so it gets the minus a negative. All right, 9 minus negative 5 is the same thing as 9 plus 5, which is 14. All right, last problem here. We have g plus 3f of x. Let's separate it out. So we've got g of x plus 3 times f of x. Okay, the 3 is only multiplied times the f function. Okay, so this is a lot like example 6. We are not actually going to be able to use the calculator on this because we have x's that are still going to be in our answers. All right, g of x is negative 2x plus 8. F of x is x minus 3. Okay, so this is a distribute and simplify type problem. Okay, the only thing that needs some distributing is the second parentheses. So let's bring down negative 2x plus 8. Okay, 3 times x is 3x, and 3 times negative 3 is negative 9. Okay, nothing really needs parentheses anymore because there's nothing multiplied. Let's just combine some like terms. Biggest exponent is a 1, so let's get those linear terms, this term and this term, combined together. Negative 2x plus 3x is 1x, or just x. And 8 minus 9 is negative 1. So g plus 3f of x is x minus 1.